Okay, so for this example, this is again from your textbook, and I'm going to look at number 21. And let me change that to the red font. I think it shows up a little bit better. So here's your binomial. It says, in a study, 90% of homes in the U.S. were found to have a large screen TV. And then it says, in a sample of 9 homes, what is the probability that, in each one of these, we're looking for the probability of success of a home having a large screen TV. So I would say, first of all, we need the number of trials, which is going to be 9, because that's our sample size. And our probability of success is going to be 0.90, which is our constant. Now, I went ahead and clipped out a picture of your appendix at the bottom here. So here's where you've got your n is equal to 9. And we're going to be focusing on this column right here, which is 0.90. Notice all of your x distributions are listed right over there. Now, to answer the first question, it says, what would be the probability that all 9 homes would have a large screen TV? So that's like saying the probability that x is equal to 9. So you go to your table, you go to the very bottom, 9x, where x is equal to 9 is right there. So where that intersects with the column, I see 0.387. So guys, that would be your answer, simply 0.387. Again, you do not need to manually calculate these, just go to your table. So that would be part A. Part B says, what would be the probability that less than 5 have large screen TVs? So less than 5, I'm going to write this mathematically, the probability that x is less than 5 would actually be the outcomes of 0 plus 1 plus 2 plus 3 plus 4. So we would basically be looking at 0 through 4. So guys, that would be basically this group right there. Okay, and simply you would add all these up, and it looks like in this case your answer is going to be 0.001 because the first 4 are all zeros. But that would be the outcomes of 0 through 4. That's how you would get less than 5 large screen TVs. So that would be part B. Now on part C, it says more than 5. So I'm going to write this out. The probability that x is greater than 5. That would be the outcomes of basically 6 through 9, so that would be right there. Okay, so more than 5, you start with 6, so you'd have the probability outcomes of 6 plus 7 plus 8 plus 9. So what you essentially would have to do is, I'm going to put these out here, you'd have to add 0.045 plus 0.172 plus 0.387 plus 0.387, and then add those up. That would give you your cumulative probability of greater than 5. Okay, now the last one, letter D, at least 7. They want at least 7 have large screen TVs. So that would be the probability that x is greater than or equal to 7, which basically means we're looking for 7, 8, and 9. So that would be 0.172 plus 0.387 plus 0.387. Once you add those up, that would give you your cumulative probability of at least 7. So again, just trying to show you this example how you would calculate cumulative probabilities using your tables. And again, you do not need to manually calculate any one of these probabilities. You should always be able to find these in the table.